Yeah, so we just saw convolution for a discrete time signal, which was like summarized by what was shown in this page. So it was nothing but you have your h of n, which we kept shifting by various values of k, and whenever you shift h of n by some k, you scale it by the corresponding x of k, and then finally you sum it all over k to give you the final y of n. Okay, so this is fine, there's nothing wrong with it, but there is an alternate viewpoint which might make it a little more easier to manually work out convolution by hand. So before we do that, we should have a quick recap, which I will show here. This is something which we saw earlier when we saw the relationship between the unit step function and the delta function. Again, the illustrations are drawn in the continuous time case because it is easier for me, but the same thing applies in the discrete time case as well. Okay, so now this is the continuous time case. This is t. So now this is the unit step function u of t, and we see the time shift of u of t, where we do u of t minus t naught. That when this t of t naught is greater than 0, it's a positive number, then it is your time shift gets delayed, right? And u of t minus t naught is also a delay, and when t naught is less than 0, your unit step gets advanced. We are calling this a delay because whatever is happening at 0 is now happening at t naught seconds after 0. And similarly, we are calling this as an advance because whatever is happening at 0 is now happening t naught seconds before 0. Okay, so this is an advance and this is a delay. This was the case when you represented the time shift as u of t minus t naught. We can also represent the time shift as u of t plus t naught. In that case, it gets reversed. For example, when you write the time shift as u of t plus t naught, and when you have t naught less than 0, then you get a delay, and when you write u of t plus t naught, and when t naught is greater than 0, then you get an advance. Fine. So this is just the reverse case. This is just because when you, in one case you represent the time shift as t minus t naught, in the other case you represent it as t plus t naught. Now, if you consider this case now, suppose we are going to represent time shift as t plus t naught. Then once you have it like this, what you do, what is u of minus t plus t naught? Okay, so this is u of t plus t naught, and so u of minus t plus t naught is nothing but, and when t naught is less than 0, this is, like we said, a delay. So now when you do, when we just replace this t with a minus t, everything else remains the same. This function here, this t naught, just gets flipping about the y-axis. So this thing which looks like this here, it now gets flipped like this. This is u of minus t plus t naught. Similarly, u of t plus t naught, when you replace t with minus t, you're just again doing a time flip. So this thing gets flipped about the y-axis. So now this, your t naught will become here, and this gets flipped. Right? So this we had seen earlier. So please keep this in mind. Okay, we are particularly interested in this particular form. That is, we are going to say a time shift in the form minus t plus t naught. We are looking at a time shift in this particular form. Okay. So to start with that, what we do now is again consider the, let me write the convolution sum y of n. I write it as the same sum, k is equal to minus infinity to plus infinity x of k h of n minus k. This is the same form which we saw earlier, right? So now we will have now, let's say there is a del of n, which gives me my h of n, and my h of n looks like this, for example. Okay, again this is a discrete time signal. I'm just drawing it as a continuous time signal just for the sake of making the drawing easier, that is all. So this is my del of n, this is my h of n, this is my input and this is my output. So now if I see this convolution like this, so in the previous case we had seen the convolution in this fashion where we had h of n and then we kept shifting the h of n by various values of k, right? When k was 0 there was no shift. When k was 1 then it got shifted, then this became h of n minus 1, and whenever we shifted we scaled it by the corresponding value of x of k. So here all of these were functions of n, all of them are functions of n, and for various values of k we are finding out how the shifting and the scaling is happening. But in the alternate viewpoint, which we will see now, we will now see this expression as functions of k rather than functions of n. Okay, we want to see the convolution in terms of functions of k. Now for example, I will just replace this h of n and I will call it h of k. I'm just doing a change of variable here. N is equal to k. Okay, there is no difference. I'm just replacing n with k. So now my h of k now looks like this, the same thing, except that now we are not considering this as a function of n, we are now considering it as a function of k. But this is actually minus k. Can you see the minus? So this is very similar to what we just said here about this minus t plus t naught. Okay, so this is minus k plus n. So now what we will do, we will compute this for various values of n. In the previous case we were computing this for various values of, in the previous case we were looking at various values of k, but in this case now we will look at various values of n. Now this is h of k, and let me also do what is h of minus k. What will be h of minus k in this case? This is my 0, so h of minus k will be flipped, so this becomes my h of minus k. Okay, let me now do h of minus k plus 1. So h of minus k plus 1 will become, this is my 0, this is my 1, this is 2, this is minus 1. H of minus k plus 1 will now become shifted like this. H of minus k minus 1 on the other hand would become, this is minus k minus 1 would become, this is minus 1, this is minus 2. This will be h of minus k minus 1. So here if you see this expression here, n minus k, this is my minus k, this is nothing but h of minus k plus 0, and this is same as h of minus k plus 1. Yeah, sorry. This is yeah, this is also h of minus k plus minus 1. So this is my n. Okay, so this is when n is equal to 0, this is when n is equal to 1, this is when n is equal to minus 1. This is when n is equal to minus 1. So essentially you can see that when you see this as if all of this are now functions of k. I'm seeing this as a function of k for various values of n. So you can see that when your n takes values which are positive, my h of minus k keeps shifting to the right side, and when n takes the values negative, my h of minus k shifts to the left side. Okay, so and now if you come back to the expression of convolution, we have h of minus k plus n, and that is multiplied by x of k. Okay, so now basically what will now happen is, now if you have your various values of x of k is also now seen as a function of k. The convolution sum is now nothing but you are summing over various values of this product, this shifted flipped and shifted h of k, and you are multiplying it with the corresponding values of x of k. To make it more concrete, we will see an example. This example is again from the textbook.